Now remember, we have two special numbers, the additive identity 0 and the multiplicative identity 1. We want to take a minute and think about how 0 and 1 interact with exponents. Let's think first about when 0 or 1 is the base. Right? Now, I'm going to show you 2 just as kind of an example. Right? 2 squared, that means 2 times 2, which is 4. 2 cubed, that's 3 copies of the number 2. That's our first 2 2's times another 2. That's 8. 2 to the 4th, that's 4 copies of the number 2, which is the first 3 times 2, which is 16. Right? Each time we go down a line, we multiply by 2. 2 to the 5th, we'll multiply by 2 again. We get 32, and so on. Let's see how this pattern works with 1. 1 squared, that's 1 times 1, that's 1. 1 to the 3rd, we multiply by 1 again, still 1. 1 to the 4th, multiply by 1 again, still 1. 1 to the 5th, multiply by 1 again, still 1, right? No amount of multiplying by 1 is going to get me any other answer than 1. 1 to any power equals 1. Right, and this power can actually be any power. 0 squared, right, well that's 0 times 0, which is 0. 0 cubed, multiply by 0 again, still 0. 0 to the 4th, multiply by 0 again, still 0. 0 to the 5th, multiply by 0 again, still 0, right? No amount of multiplying by 0 is going to get us anything except 0. 0 to any power is 0. But there are some conditions on this exponent that we're going to see in a moment. Certainly this works for whole numbers bigger than 2. So that covers what happens when 0 or 1 is the base. Let's think about when 0 or 1 is the exponent. So 2 squared is 2 copies of the number 2 multiplied together. 2 to the 3rd is 3 copies of the number 2 multiplied together. It stands to reason that 2 to the 1st power ought to be just 1 copy of the number 2. 2 to the 1st power ought to be 2. Right? The pattern that we saw earlier still holds. Every time we add an extra copy of the number 2, we multiplied by 2. Similarly, we might expect that 3 to the 1st power is just the number 3. Again, the pattern, multiply by 3 each time, holds. And that is the rule that we see. Any number to the 1st power is just that number. It's just 1 copy of that number. It's just the number itself. The 0th power is a little bit trickier, but look at the pattern. Whatever 2 to the 0th is, when I multiply it by 2, I'd better get 2. Right? 2 to the 0th had better be 1, since 1 times 2 is 2. Similarly, whatever 3 to the 0th is, when I multiply it by 3, I'd better get 3. 3 to the 0th had better be 1. Alright, what sense does that make? To say 2 to the 0th, or 3 to the 0th, or whatever number to the 0th has to be 1. Right? You should think the 0th power means don't multiply at all. The number that doesn't do any multiplying at all is the multiplicative identity 1. One important thing to be aware of here. We have one rule that says 0 to any power ought to be 0. We have another rule that says any number to the 0th power ought to be 1. Right, what should 0 to the 0 be? It isn't. 0 to the 0 is undefined. 0 to the first power, we're still okay. 0 to the first power is just one copy of the number 0 multiplied together. We're all right there. But then if 0 to the 0th power tries to answer the question, what times 0 gives me 0? Well, this could be anything, right? This could be anything, so it's not any specific thing, so this is undefined.